welcome to today's class. So in this video I'm going to be explaining particulate nature of matter, valency and formula. So let's get right into today's class. Matter. You should be very familiar with matter now. We said matter is defined as anything that occupies space and has mass. So the particles of matter could be atoms, molecules, or ions. Matter exists in three states. We have the solid, liquid, and gaseous state. Now, looking at the Dalton's atomic theory. Dalton is a Greek philosopher, and he was the first to put forward the idea of atom being particles of matter. So atom is a Greek word meaning indivisible. So in the words of the Greek philosopher, matter is made up of small particles. This statement was established by John Dalton, an English scientist, in 1808. He put forward the following theories describing the nature of matter. Number one, he said matter is made up of small indivisible particles called atoms, and atoms can neither be created nor destroyed. Number three, he said atoms of a particular element are exactly alike, and they are different from atoms of other elements. And lastly, he said that chemical combinations are taking place between whole number ratio atoms. So let's look at atoms. In this class, we've defined atoms before. So we said atom is the smallest chemically indivisible particle of an element which can take place in a chemical reaction. And atoms, two or more atoms, can unite to form a molecule. Now, molecule. The molecule is the smallest particle of a compound which retains the identity of the compound. A molecule is formed when two or more atoms join together chemically. A molecule is also known as molecule of a compound when it contains different atoms, as in the case of sodium hydroxide and calcium chloride. So we can see atoms of sodium, oxygen, and hydrogen there coming together to form sodium hydroxide. Then atoms of calcium and chlorine coming together to form the calcium chloride. When the atoms are the same, so when we have two atoms of the same element coming together, the molecule is known as the molecule of that element. For example, when we have atoms of hydrogen coming together, in this case two atoms of hydrogen come together to form hydrogen molecule, and two atoms of oxygen come together to form oxygen molecule, or molecules of oxygen. Ions. An ion is any atom or group of atoms which possesses an electric charge. We have two types of ions. We have the positively charged ions, which is also known as cation ions. Example of that, we have the sodium ion, calcium ion, iron ion, aluminium ion, and so on. And next we have the negatively charged ion, which is also called anions. Examples include chloride ion, oxygen ion, hydroxyl ion, and trioxonitride ion. Moving forward, there are some natural phenomena, or phenomena in this case, that we use to support the statement matter is made up of particles. So diffusion, for example, diffusion is the movement of a substance from a degree of higher concentration to the degree of lower concentration. So this, all of these statements, even evaporation, when we boil a liquid, it evaporates and we see what we call vapor moving forward. All of these proves that matter is made up of what we call particles. Osmosis, Brownian motion, sublimation, all of these prove that matter is made up of particles. Now, let's look at modifications that have been made to John Dalton's atomic theory. Number one, he said that matter is made up of small indivisible particles called atom. Now, this is no longer true because in some radioactive atoms, they undergo spontaneous degradation or artificial degradation to produce helium. And helium is actually smaller than an atom. So helium. Then we also know that atoms are made up of subatomic particles known as protons, neutrons, and electrons. So in other words, we can no longer say atom is the smallest indivisible the smallest indivisible particle anymore of matter because of this discovery. Number two, he said that atoms can neither be created nor destroyed. Now, during a chemical reaction, we notice small changes in mass due to energy changes. For example, when we add water to sodium hydroxide pellets, the reaction is exothermic. So energy is being released into the atmosphere. Therefore, some matter must have been destroyed through the energy going out. So that negates John Dalton's atomic theory number two. Number three, he said atoms of a particular element are alike and they are different from atoms of other elements. Now, the discovery of isotopes make this statement unacceptable. What are isotopes, or what is the phenomenon called isotopy? Now, isotopy is a phenomenon whereby atoms of the same element possess the same atomic number but different mass number. And we see the case in atoms like chlorine, oxygen, and some other compounds like that. They have different mass number but the same atomic number. So this negates Dalton's atomic theory number three that says that atoms of a particular element are alike. So sometimes isotopy negates that theory. So the last theory of John Dalton is that chemical combination are taking place in small whole numbers. Now, when we look at organic compounds, especially polymers, they are made up of large numbers of atoms coming together. Large number, we see atoms C12, H22, O11, atoms like that. Those atoms are not made up of small number of atoms. Polymers actually have large. We have polymers of C100. That's 100 carbon coming together. So that negates that theory. So let's look at the atomic structure. Looking at the atomic structure, we know that atoms are found to contain three types of particles: protons, neutrons, and electrons. It consists of the centrally placed nucleus, which is surrounded by a cloud of electrons. So inside the nucleus we have the proton and the nucleus. So I'll explain that on the board. Now let's look at the properties of the subatomic particles of atom. Now looking at the properties, we have proton having a mass number of 1, and we already said protons are positively charged, while neutrons also possess a mass number of 1, and a neutron is neutral, it has no charge. Electrons have a mass of 1 over 1840, and it is negatively charged, so it is having a charge of -1. So we have the nucleus at the center, and we have what containing the nucleus, we have our protons and neutrons. Then we have electrons roving round the orbit, and we said electrons are arranged in what we call, based on what we call electronic configuration. An electronic configuration talks about shells in which electrons are arranged. So we have 7 shells with which electrons are arranged, and these shells are denoted by symbols K, L, M, N, O, P, Q. The nearest shell to the nucleus is known as the K shell, and this shell, the one after that, sorry, my drawing is not very good, the one after that is called the L shell, and after that the M shell. So there is a formula with which we use in knowing the number of electrons that each shell would carry. For instance, K shell is shell number 1. So the formula with which we use is 2n squared. So since K shell is number 1, so for K shell we say when n equals 1, so our K shell will contain 2 bracket 1 squared, and that will give us 2 electrons. In other words, the K shell can only contain 2 electrons. So let's look at our L shell. L shell, that's the L shell. When n equals 2, we have 2 bracket 2 squared, and that will give us 2 squared is 4. 4 times 2 will give us 8. That will be 8 electrons. So the same way we continue. For the M shell, we have 2 bracket 3 squared. So 3 squared is 9. 9 times 2, that's 18 electrons. So the cycle continues for the N, O, P, Q, like that. Now, in our next class, we are going to be talking about atomic numbers and mass numbers. So thank you for watching this video. Please don't forget to subscribe to this YouTube channel so that when we post content on mathematics, chemistry, you would be notified. So in our next class, we're going to be talking about atomic numbers and mass number. Basically, we're going to go into, we are gradually getting into chemistry, the core of chemistry. So see you next class. Bye.